and we like lit our hands on fire. It was so
We have this cool thing, like these balls, and like you pull one of the balls, and like all, then the other ball on the other side would like what?
All right, so page 9 and 10 was your homework, so have that out. Come by, mark it off. Page 9 and 10 was what we did last time. So let's take a look at 1 through 8. Anything on 1 through 8 you'd like to see? Anything on 1 through 8 from last night's homework on page 9 10? Yeah. 8, okay. Number 8. So that's 20x to the negative 3 over 5x squared. Okay, I can go ahead and reduce the 20 over 5. The 20 over 5 is going to reduce to 4 over 1. We can put a 1 right now, but we don't have to. And then we have to understand that this is a negative exponent, so it's going to move down. So it's going to join the others that are downstairs. So how many x's are going to be on the downside? 5. Good. And there's our answer. Okay. Any other questions from 1 through 8? 1 through 8. Yeah. 6. You got it. Number 6. 3x squared times 2x to the 9th. Okay. Everything's going to combine together. No negative exponents. So 3 times 2 is 6. And then like bases that we're multiplying, we're going to add the exponents. Ooh, what? Number 3? What did I get? Let me see. Number 3, I can do right here. Okay, so that's a negative exponent, so it wants to switch. So right now this is a numerator because I could technically put this over 1. Do you agree with that?
Yeah.
So if that moves down, that means there's going to be a 1 on top, and then I get 3 to the 4 on bottom. You could probably leave it like that, but you could also figure out 3 to the 4th is 3 times 3 times 3 times 3, which is 1 over 81. Yeah, gangity, man. Yeah. Anything else, 1 through 8? Okay, 1 through 16. 1 through 16. Anything else on 1 through 16? Yeah. 13? Okay. Okay, we can go ahead and start combining things together. So 3 times 7 is 21. I have x squared, x to the 3rd. We're multiplying the bases. Excuse me. So we can add the exponent. So that's x to the 5th. Y to the 4th, y to the 5th. We're multiplying bases. So we add the exponent. So we get y to the 9th. What else? Yeah. 16. 15 and then 16. You got it. Let's squeeze them both right here. Number 15 looks like this. Number 16 is this. Okay. So number 15, I can't reduce 2 over 3 at this point, and I have no tug of wars taking place. So I'm going to distribute this to here, and to here, and to here, and to here. So 2 squared is 4. X to the 3rd to the 2nd, power to power, on top of each other, so they multiply, so I get x to the 6th. 3 squared is 9. Y to the 1st to the 2nd is y to the 2nd. So that's number 15. I have 3 of these I'm multiplying together, so if I distribute that here, and here, and here, 4 to the 3rd is 4 times 4 times 4. So 4 times 4 is 16. 16 times 4 is 64. A to the 4th to the 3rd, so power to power, they're on top of each other. You multiply exponents, so A to the 12th. And then B to the 5th to the 3rd, so power to a power. The exponents are on top of each other, so they multiply. So I get B to the 15th.
Hold on, mister.
Holding on.
Oh, I see. Because I got, I got 4.
Oh, I think you probably just left the 4 alone.
So you have to do the 4 times 4.
Yeah, so that comes here. So what this written out is, if I didn't have it to a power, is this, this, and this. So the exact same thing written 3 times. So you'd go 4 times 4 times 4, 64. A to the 4, A to the 4, A to the 4, A to the 12, B to the 5th, B to the 5th, B to the 15.
All right.
Cool? Yeah. 12? All right. Okay, we don't have any negative exponents. We don't have the same bases on top and bottom, but there's not an x on top and an x on bottom or anything like that. But at this point, it looks like we can do tug of war. So who wins on the x's, top or bottom? Top by how many? Three. Tug of war with the y's. Who wins, top or bottom? Bottom by how many? Two. Done. All right, let's flip the page. So on page 10, any questions you'd like to see? Any of those? So 17 through 30.
Number 12.
12? Okay.
I'm not got it. Never mind.
Oh, you got it. Go ahead.
26.
26. All right, 26. We have 8xy. Okay, we have a power outside on the bottom. Do you agree? So let's take care of that first. We are not going to reduce 8 and 4 at this point because this needs to take place first. So this is going to come here. It's going to come here. We'll have a negative exponent. That's fine. We'll take care of that bit. That comes there, okay? So on top, I'm going to get 8xy. And on bottom, I get 4 squared, which is 16. Oh, the 8 and 16, I'll have some reducing. X to the negative 1 to the second, multiply, so I get x to the negative 2. So that'll have to move. And then y to the third to the second part of power, they're on top of each other, multiply. So y to the 6. Looks like we'll do a tug of war with the y's at this point. Is that everything okay so far up there? Okay, let me just... Okay, so let's start reducing. 8 over 16, you get a 2 on bottom. There's a 1 on top. We could leave it there. This wants to move up. So if that moves up, how many x's are up on top? 3, because that's an x to the first on top right there, right? So that becomes x to the third on top. Tug of war with the y's. Who wins, top or bottom? Bottom by how many? 5, because that's an x to the first, so tug of war, so the bottom wins by 5. Anything else on that back page, page 10? Yeah. 2, 4. Okay. Okay, does it look like I have that written down right? 3x squared. Y to the negative 4 squared. Okay. We do have negative exponents and such, but we can leave them in place until we get done with our distributing. So that's going to come here. So that's 3 squared, which is 9. X squared squared is x to the 4th because they multiply. That's going to become y to the negative 8. And then I get 2 to the 5th. Let's see, 2 to the 5th is 2 times 2, which is 4. 4 times 2, which is 8. 8 times 2, which is 16. 16 times 2, which is 32. And then that comes there. That's x to the negative 10. That comes there, y to the 15. We could probably multiply 9 and 32 together. So 9 and 32, let's see, that's 18. Carry the 1, 27, 28. 32. 2 to the 5th, 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Cool? All right. Let's see. I do have some negative exponents, so let's write this without negative exponents. So I have x to the 4. This one's going to move down. This one's going to move down. And then y to the 15 stays on top. Okay, the 288 stays as is for right now. Tug of war with the x's. Who wins, top or bottom? Bottom by how much? 6. X to the 6 on bottom. Tug of war with the y's. Who wins, top or bottom? Top by how many? 7. There's my answer. Time for one more.
28. No. 25. You should do 28 though.
Total reward just reduce 15 over 10, so that's 3 over 2. Switch the x to the 11th is on bottom, y to the 12th is on top, the negative exponents. Anyone want to see the scientific notation, anything like that? That's 19. All right, 1.59 times 10 to the negative 8. So the negative 8 means my decimal is going to move 8 spots to the left. Okay, so I'm going to have 7 zeros I'm going to add. So I have 1, 6, 7. So that's what that number represents. Yeah, because this means I'm going to move the decimal to the left and get rid of it. If it was a plus, then you'd move it. If this was just an 8, it would go to the right, but it is a negative, so it's this real small decimal. Okay, make sure your name is on the top of that page, please, and pass that page on forward. Okay, so we are kind of going into a new part of this unit, which is still a part of the same chapter, but it's a new part. I want to remind you that there is a Schoology quiz 2. It's due Friday by 11:59. Some of you who have already taken it kind of goofed it up. You tried to go through real quick going, I'll just guess. Well, if you guess wrong on multiple choice, guess what? So that'll be due at 11:59 on Friday night. And then you want to make sure you're doing those because they definitely will help you with your test quiz scores. Look under, at the very top of my Schoology page when you get to our thing, is an orange folder that says second semester, so go into that. You scroll to the bottom of all the other stuff, that's all first semester. So I should have thought a little more forward thinking. I should have thought to create a first semester folder and a second semester. I'll do that for next year. I become a better teacher each year. One day I'll become really good, but that's probably 30 years from now when I'm teaching your guys' kids. 30 years from now puts me at 77. If I still have bouncing my step at 77, man, that would be all right. All right, so let's get a couple definitions down. So we have on the top of your page, you have 2 boxes or 2 bubbles of some sort. And here it talks about real numbers. And then you have a bubble here that talks about rational numbers and integers. And then we have another bubble that's called irrational numbers. And then over here, these are non-real numbers. Okay? So let's just, by definition, talk about what each of these are. An irrational number is a decimal that can't be made into a fraction. Okay, that was about the worst writing ever. Okay, it can't be written as a fraction. So if you had the decimal, say 0.6, that's the same thing as 6 over 10. Okay, so that decimal can be written as a fraction. And then we can even have like 0.125. 0.125 is 125 over 1,000, so it terminates. If we had, say, like 0.3 repeating forever, 0.3 repeating forever can be written as 3 over 9. Okay? So those are all rational, but an irrational decimal is a decimal that doesn't repeat. And the most common one you've seen is pi. It goes out 3.14159, keeps going forever and ever. There's not a fraction that we can have that's equivalent to that decimal. Yes, some of you might say, oh, well, 22 over 7 is the fraction. No, 22 over 7 is close, but it's not the fraction that goes with it. So an irrational number is a number that you cannot a decimal that you cannot write as a fraction. So a lot of times you'll see a decimal, say like 0.732 ... That means that ... means that fraction keeps going and going, and we can't find the pattern to it to find the fraction. So irrational numbers are decimals that can't be written as a fraction. Rational would be decimals that can be written as a fraction. It could be fractions. Obviously, if it's a fraction, it can be written as a decimal. Integers, which are negatives and positive numbers, and then real numbers encompass the decimals and the fractions and all the other numbers that you've ever dealt with. And then non-real numbers, and they're sometimes referred to as complex numbers. This would be if you had the square root of a negative number. This is the letter I we use to represent it. And I stands for a non-real number. Okay? So, if you have a square root that has a negative in it, it's complex.
Mister, did I say FN?
Right here?
No, the other one. Next to it.
That's the square root of negative n. Okay, now, real quick question. If I have the third root of negative 8, do you think the third root of negative 8 exists?
Wait, it says equals what?
It does.
I, lowercase I, square root n. So, let me ask you all this. If I took negative 2 and negative 2 and negative 2 and multiplied it together, let's see, negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is what? Negative 8. Okay, so the third root of a negative number does indeed exist. Okay? So, if you have a square root, or a fourth root, or a sixth root, or an even root of a negative number, it falls into the non-real category. Okay? So now, with those little definitions, I want you to go to your second page, which is a big old thing of all these numbers. So, let's identify 1 over 3. 1 over 3 is a fraction. Is it rational, irrational? Is it real? Is it an integer? Is it non-real? What do you think? It's rational. Any fraction is rational. Negative 4. It's rational. Okay, it's also one of the real numbers. Okay. Square root of 5. Ooh. Ooh. Square root of 5. If I did the square root of 5 on my calculator, I want you to see what it comes out to. So if I did the square root of 5 on my calculator, do you think that that decimal conveniently ends all the way out there to the right? Or do you think it would keep going? It'd keep going. So square root of 5, it's a decimal that's never going to repeat. So is it rational, irrational, real, non-real? What do you think? Go ahead. Do what?
Irrational.
It's not irrational. It's not. Or it is irrational. Thank you. Square root of 9. What's the square root of 9?
3.
3. So square root of 9 is 3, so it's rational. 0.25. 0.25 I could write as 25 over 100. So it's rational. 2 falls into the real. It's an integer. Go with that. 1 over 4. Rational or irrational? Rational. Pi. Pi as a decimal goes forever and ever. Rational or irrational? Irrational. 0.625 can be written as 625 over 1,000. Of course, you could reduce it. What's 625 over 1,000? Is it rational or irrational? Rational. 21. It's an integer, right? Square root of 12. Okay, so if I went on my calculator and hit square root of 12, look how far that decimal goes. Do you think it keeps going?
Yes.
Heck yeah. Is it rational or irrational? Irrational. Okay? It's irrational. 2 over 5, well, it's written as a fraction, so it must be rational. 0.3 with a bar. So 0.3 with a bar is the same thing as 1 divided by 3. Or 1 over 3. Or 3 over 9. Is it rational or irrational? It can be written as a fraction, so it's rational. Negative 3/4, it's written as a fraction, rational or irrational? Rational. Negative 15, it's an integer. 6.1. So 0.1 can be written as a fraction, that's 1 over 10, right? So is 6.1 rational or irrational? Rational. Yep, doesn't repeat, good. Negative 12 over 3 reduces to negative 4. Rational or irrational? Is it an integer? Could be classified as an integer because it reduces. So if pi can't be written as a fraction, if I multiply that by 2, do you think it'd be goes on forever, so it's irrational. So, do you think 2 times pi is rational or irrational? Irrational. Square root of 8. Square root of 8 is going to be like square root of 12. It's irrational, keeps going forever.
Every square root would be irrational.
If it's a perfect square, no.
What's a perfect square?
Like number 9, square root of 9, it's 3. Right? Okay, 1.4121 ... The ... means it goes on forever and ever. There's no pattern.
Oh, okay.
Irrational. What about negative 3 over 5? Rational. 7. Rational. It's also an integer. The square root of 3. The square root of 3 is going to be a big old long decimal. Never repeats. What do you think? Irrational. Square root of 100 is 10, which means it would be rational. 0.5 could be written as a fraction. That would be 5 over 10, which reduces to 1 over 2. So is 0.5 rational or irrational? Rational. The negative of the square root of 2. Rational or irrational? The decimal keeps going forever, so it's irrational. 1 over 10. Well, I could write it as a fraction, so it must be rational. If I add 1 to pi, pi was already irrational. Do you think it's going to change things if I add 1 to it? Nope. So that's got to be irrational. 0.55, it ends. 0.55 could be written as 55 over 100, which that could be reduced. So is 0.55 rational or irrational? Rational. What about negative 1?
Rational.
Rational. It's also an integer. 150?
Rational.
Rational. It's also an integer. 1 over 9?
Rational.
That is rational because it's obviously a fraction. So it could be actually 1 over 9 is 0.9 repeating forever. Let's see. 0.1 with a bar above it means it's going to go 0.1111. So it's going to have a pattern. So it's rational. 0.1 is actually 1 over 9. Okay?
You did just say that.
Hey, they were right next door to each other. Huh? Oh, okay. Negative 10 over 2 reduces to negative 5. So it's an integer, it's rational, it's real, it's all those things. 3. It's a real number, it's a counting number, it's an integer. 12.05. 0.05 can be written as a fraction as 5 over 100. Of course, that would reduce. So is 12.05 with a bar above the 05? Rational. Actually, 12.05 repeating is going to be, it's not 5 over 100, it's 5 over 99 actually, which still would work. So that's rational. Negative 1/5, rational or irrational? It's got to be rational because it can be written as a decimal. Okay, if pi is irrational, do you think it makes a difference if I divide by 2 now?
No.
Nope, it is still irrational. The square root of negative 10. Non-real. Good. So the square root of negative 10 falls into this category. That's the square root of a negative. The negative's under the radical sign. 6.513 dot dot dot. 6.1, that's irrational. Keeps going. 4 raised to the third power is 4 times 4 times 4, which is 64. So what do you think? It's rational. It's a real number. It's an integer. Ooh, 16 to the 1/2 power. I will tell you that 16 to the 1/2 power will clarify a little bit better today, but 16 to the 1/2 power is actually the square root of 16. What is the square root of 16? 4. So is that rational or irrational? If it's rational, is it a integer? Yeah. The third root of 8. Is there a number times itself that gives us 8? Well, it'd be 2. 2 times 2 is 4 times 2. So 2 times 2 times 2 is 8. So the third root of 8 is 2. That is an integer. The third root of -1, well, is -1 times -1 times -1 the same thing as -1? So the third root of -1 is -1. That happens to be rational, happens to be an integer. 7 to the 1/3 power. Ooh. Let's see if the calculator will do something like this. Okay, 7 raised to the 1 divided by 3 power. Oops. Seven to the 1/3 power. You think that decimal keeps going? Heck yeah. So 7 to the 1/3 power has got to be what kind of number? Irrational.
So a number with a fraction will be irrational.
10 to the -2 is 1 over 10 squared. 1 over 10 squared is 1 over 100. So is that rational or irrational? Rational numbers are fractions. So 1 over 100 is rational. Ooh, 27 to the 2/3. We'll come back to that. 27 to the 2/3 is actually 9, but we'll come back to that. 8 to the 1/2 power. The square root of 8. The square root of 8. If I use the calculator and find the square root of 8, I get 2 point big old long decimal. Rational or irrational? Irrational. The square root of -4.
Or -4?
Yep.
-2?
Not -2. It's actually 2i.
Oh.
So it falls under the... Where does I exist?
Non-real.
Non-real. And then parentheses, -5 squared. So that's -5 times... It's rational because it would be 25 and it would be an integer. Okay?
-25.
Positive 25 because it's grouped. Yeah. If it was -5 squared with that parentheses, it's -25. But if it's grouped together, held together. All right. So let's go back to the very front page. And if you have your calculators, this would be extremely helpful. If you don't have a calculator, you don't have enough fingers and toes to do this. Okay? So we've asked you to get a calculator. We've asked you to rent them if you could. So we want you to use your calculator to find the following. So 8 to the 1/3 power. So I'm going to go 8. I'm going to use this little caret key right here. I'm going to use parentheses. 1 divided by 3. Close the parentheses. That's 8 to the 1/3 power on my calculator. Okay? If I hit enter, that says what number times itself 3 times is 8. Oh, it's 2. 2 times 2 times 2 is 8. The next one, if I do 27 to the 1/3 power, I go 27, the little caret that's above the division sign, using parentheses, 1 divided by 3, hit enter, 3 times 3 times 3 is 27. 64 to the 1/3 power, caret, is 4, because 4 times 4 times 4 is 64. So that little caret key allows you to raise an exponent. An exponent can be a fraction. Okay? So let's discuss what that really means. Back to this page. Here, here. I have this rule. Okay, take a look where this m falls. So that numerator of your fraction of your exponent becomes what's your multiplier. Okay, how many times is being multiplied? Look where the n falls. The n is the denominator, so the n, the denominator, becomes what root? Now, if you see this is equal to that, having a 2 right there. We just don't put it as 2 there because math folks are lazy. They're looking for ways to do shortcuts. So it's like, well, if you have a square root, it's obviously square root, so there's a 2 there. Okay, so if you have the square root of something, there's actually a little 2 there. Okay? So if you look at problem number 1, x raised to the 3 over 2. I would like to write this as a radical expression, meaning I want to use some sort of root. Okay? So things that I know is this. I know x is going to be inside. Let's figure out where the 3 and the 2 go. Where does this 3 go now? It goes inside right here. Okay, where does this 2 go? Right there. So this is asking for the square root of a cube of something. That's for the square root of a cube. The next one, y to the 1/4 power. So I will tell you that y lives in here. Where does this 1 live? On top of the y, right? Where does this 4 live? Yeah, it's asking for the 4th root. It's asking for the 4th root. Okay, rewrite each expression as a radical and classify it as an integer. So is it some sort of counting number? A rational number, meaning something that could be written as a fraction. Irrational number, meaning you can't figure out what the decimal would be as a fraction. Or a non-real number. Okay, so problem number 1, I have 24 to the 1/2 power. That's going to be the same thing as the square root of 24 to the 1st. Can I find the square root of 24? I can find the square root of 25. It's 5. Can I find the square root of 24? No, it's 4 with a big old long decimal. If it has a big old long decimal behind it, is it rational or irrational? Irrational. IRR. Okay. Number 2, 16 to the 1/2 power. If I write this as a radical, I get the square root of 16 to the 1st. 16 to the 1st is just 16. What is the square root of 16? 4. Is 4 rational or irrational? It's rational, right? It's a integer. So rational is an integer. Okay? Number 3, 2 to the 1/2 power. That's the same thing as the square root of 2 to the 1st. If I find the square root of 2 on my calculator, it's 1.4 with a big old long decimal behind it. So is it rational or irrational? Huh? How do you what? On a calculator? You have second, and then my square root key is the x squared. Okay. Number 4, 8 to the 1/3 power. 8 to the 1/3 is the same thing as saying the 3rd root of 8 to the 1st. 8 to the 1st is just 8. So what times what times what gives me 8? 2. Rational or irrational? Rational. Integer? Yep. Number 5, parentheses. This is going to be the same thing as the square root of negative 4 to the first. Square root of negative 4 comes out to 2i. Is it rational or irrational? Or is it non-real? Non-real. And the real means that's the name of the number system. Number 6. Number 6, we have 4 over 25. And that's raised to the 1/2 power. That's the same thing as saying the square root of 4 over 25. The same thing as saying the square root of 4 over the square root of 25. What's the square root of 4? Still have a minute and a half. 2, what's the square root of 5? Or 25? 5. It's a fraction. Is it rational or irrational? Rational. Okay? So, ladies and gentlemen, again, I don't have any more pages to hand out to you. It's your responsibility to get your book. I've told you how to get your book, so please get over there and get there. So you are to work on tonight pages 11 and 12. Page 11 and 12 is your assignment. Also, there's the thing on Schoology. Go have a great day, everyone. Take care of one another. You too. See you guys tonight.